So to boil that down again to, you know, be comfortable for being thrown in the deep end and finding a problem or finding a way out of it or a way, or I shouldn't say a way out of it, a solution for it, regardless of what the conditions might be. That's definitely a very valuable lesson I've come to learn.
Awesome. Yeah. So, question I like to start out with, what led you to decide on engineering as a degree? Take us through kind of story of your life. How did you get to become an engineer?
I grew up in Florida, so naturally, Florida, Space Coast are kind of intertwined. Seeing some of the space shuttle launches as a kid, I remember vividly seeing one go up when I was a lot younger. And even just growing up, you see some of the other launches from where I was living, even though I was over on the other coast, you could still see, a very slight streak in the sky, a little red dot way in the distance. But, nonetheless, it's like, okay, that's a rocket. It's cool. Um, so I got heavily involved in, or heavily interested in generally aerospace, space exploration, engineering. And then when I was starting to grow up, got more interested in a lot of the military and defense, primarily still on the engineering side as well, building stuff, doing a lot of drones and work of that nature. And then fast forward to high school, things, projects started getting a little bigger. Started making my own little rocket engines and drones and also all sorts of stuff. And well, fast forward a few more years and here we are. So
During your time as an engineering student, what would you say is your biggest challenges and how did you overcome those?
honestly, I had a misconception I think a lot of engineering students have when they come in. They say, okay, yeah, we'll be very hands-on, very like, okay, project based, where it's like, okay, you're in a class, for example, you're given a problem. Okay, think of a solution, analyze it, figure it out, present it as a viable option, right? The biggest challenge for me is that that wasn't necessarily the case for a lot of different classes because they were so heavily theory based and say, okay, hey, here's a random example. Here's theoretically how to calculate the lift over of some curved airfoil with these geometries and all that, which is cool. But it was a little bit of an eye-opening experience because the engineering and the self-taught knowledge I was doing for a few years beforehand, learning how to let it build everything, do I can't tell you how many thousands of hours of CAD and just act like be very, very, very hands-on. Okay, hey, I have a design problem that I'm making for myself. Here's a solution I'm going to make. 2 hours later, I have it off the printer, and there it is. It works. Great. Perfect. Whereas coming into the classes, it's very much a different approach where it's like, okay, hey, here's a problem. Here's a mathematical way to solve the problem. And then you kind of move on. That kind of stage of actually hands-on design comes at a much later on stage, which at first was a pretty big challenge for myself, if I'm being honest. Um,
Yeah.
but I think knowing the mathematical tools before the pure design phase can be helpful. But if you're very much so a hands-on person like I am, at first it can be a kind of a newsflash kind of moment.
That's definitely something I felt too. I'm very much like you. I love the hands-on stuff. I love kind of figuring out my own solutions and putting the pieces together and making sure it works. That is definitely something that I didn't know coming into engineering. That's definitely a challenge I've had as well. What's the most, what would you say is the most valuable thing you've learned as your time as an engineering student so far?
I'd say being able to accept the fact that you will not be comfortable in any way, shape, or form. You're going to want to do a lot of other things instead of sitting at 4 in the morning in the union, working on whatever problem set. And just to get used to that. I mean, like I fell in love with that kind of process. I love being awake, working on that stuff when I know most other people will probably be sleeping. And the challenge of getting to that mindset, it's a very much so an uphill battle. But once you get there, like you get that sense of okay, hey, no matter what problem you get thrown at you, you will find a way to figure it out regardless. Yes, it might take 2 weeks to solve, but you will figure it out.
Yeah.
Um, I think just having that set in stone is not only from an engineering and critical thinking perspective, but from a character development perspective. But nonetheless, getting into that mindset of all right, give me the problem, I'll get it done, no questions asked. That's by far the most valuable skill so far.
I really agree with that. I find myself kind of feeling that feeling as well that you are being faced with a problem and just that confidence and being all like, I know I'll figure out a way to solve it, even if I don't know right now. engineering really teaches you that you're faced with problems all the time that you don't know exactly how to solve. And it really gives you that confidence in yourself that even if you don't know exactly how to solve the problem yet, you'll find a way and you can just keep working at it. Internship experience, I know you worked at Lockheed and now you're running your own business, Limitless Aero. So first with Lockheed, obviously sensitive information there, but what was your role at Lockheed? What was your kind of day to day there at Lockheed?
Yeah, so I actually started working there out of high school. I used to do a lot of CAD design in high school. So I wound up designing this whole ground to hypersonic turbine integrated platform. I was a bit of a nerd.
Yes.
So I spent during COVID, I was quite literally doing CAD for 9, 10 hours a day just because I could. Um,
Yes.
Lockheed had a lot of interest in that, and started getting, at that time I kind of got pulled into just doing some work over there. I started doing a lot of more systems engineering, going from like requirements verification, looking at a lot of blueprints and being able to make sure they're actually validated on some CAD platforms. And at the time I was working on the Trident 2 D5. It's a big submarine launched ICBM. So later on, I wound up doing more hydrofluids analysis, doing a lot more of CFD work. And then I wound up going out to California for a bit, working at Skunk Works at the Advanced Development program. So um, that's kind of the summary of my work. I went from initially, again, more the design verification to the analysis to some more design oriented work, which is, effectively what I do right now. Um, and it was really neat. I think it was a really useful set of experiences. And each one was different than the other, doing different kind of work, just really broadening your exposure to a lot of different applications and of what you might be learning. As like a traditional student, most people you only see what you see in class, but the second you start actually doing applicable work with that, it's a completely different story.
A lot of students wait, until college or something to work for a big company like that. So how was that, while you were still in high school, how did you balance, doing both of those things?
Precariously. It was during COVID, so you had a lot more, I'd say a lot more available time. I don't like to use the word free time because look, there's always something you could be doing. But you had a lot more available time to be doing a lot of different things. So I personally spent a lot of COVID at home, just health considerations for family, just making sure everyone was squared away. And because of that, I was able to do a lot of my own, obviously classwork, a lot of my own personal CAD designs I was working on I was doing that many hours a day plus being able to do Lockheed work at the same time. So it was very much so a time management. It was more of a time management challenge than anything. But it was a very, very valuable experience being able to say, okay, hey, you have, these classes you got to get done. Great. You have obviously work that you're doing, whatever it might be. And then, whatever your other personal interests might be outside of just, your standard school work kind of balance. So yeah, it was very cool. Very interesting time.
And how was your feeling, obviously doing work for Lockheed while you're still in high school, obviously, is very amazing and must have taught you a lot of valuable things for sure. So how was that feeling going into college? Did you feel kind of ahead of the curve almost? Did you feel confident or did you feel like, what was your feeling going into college after doing all the work?
Yeah, it was actually one of my gripes going into college because I felt that, and again, the people I was working with at Lockheed, they were very brilliant people, very, very helpful. Get off a meeting to be able to help you on something. So I had a mentor there. He was amazing. Um, so coming into college, it was a very, very different design approach. The academic approach and the learning approach versus the actual applied approach. At Riddle, they always teach the very heavy theory approach, very basically a pure mathematical approach. I mean, realistically, the freshman year, you do a basic introductory CAD, computer design class, but then the only time you really touch any CAD is all the way in your preliminary design in senior year, right? Which, that's a different story that I really don't agree with. So that's a that's another thing. Whereas there, it's like, okay, hey, you have a design problem. All right, you have access to ANSYS, all these different CAD programs, these analytical tools, everything that you might not even have to manually calculate anything. You can literally have a design, do some design flow optimization, do all your stress simulations, fluid sims, whatever it might be, and then, propose that as a design solution, right? So it was a very, very different style of what I would say engineering and approach to problem solving. So when I got here, I was almost preemptively primed for that kind of thinking in terms of, okay, hey, I'm waiting for a problem to be given to me, so or waiting for a problem to solve, so that I can then say, okay, hey, I know where I can get access to CAD programs, these analytical tools. All right, boom, let's start problem solving, right? Whereas the stark realization was coming here. It's like, okay, no, the way you're being quote unquote taught it is through, all right, rigorous mathematical formulas, going through the mathematical process before you even touch a design. So that was very much so a completely different type of thinking, if you will, going from again pure applied to now basically pure theory. Um, and so because of that, I felt over prepared in a lot of areas, but at the same time very underprepared in certain ones. I had a very good understanding of realistic use cases and how you would actually go about solving a problem. But it was very eye-opening. I shouldn't say eye-opening, but it was a very different style of thinking going from that to a pure analytical and theoretical approach. Um, so in that regard, it was unique, I'd say.
Yeah, that is definitely very unique. And something that I'm curious about is, since you've kind of had experience with both now, right? You've had experience with the theory, kind of Embry-Riddle, learning how to do that, and for sure experience with the applied. What would you say, obviously they're both valuable, but in terms of, your success at your internships and now the company that you run here, what is the skill set or which skill set would be the most valuable for you in your position now?
I say hands down by far the hands-on. All right, you have a problem. Look, there's tons of, and look, I don't mean this in any way to annoy any mathematicians. I incredibly respect that. I personally love math as well, but the the amount of time it takes to solve a problem with the given tools we have today, in terms of being able to go on to CATIA, being able to go on to Fusion, whatever CAD program you have, being able to go into ANSYS, right, and be able to use that whole simulation analytical suite and be able to actually say you have a given problem, be able to basically have a design solution end of day for whatever part it might be, right? I think that approach is significantly more valuable from both not only a realistic use case perspective as well as teaching students because well when you go into the field, right, it's not you're realistically you're not going to be sitting there not unless again you're a tooling engineer where you're building analytical tools and basically analysis programs. That's a different story. Yes, you need all that hardcore math, all the derivations, all that kind of skill set. But I think most people go into engineering think they want to, hey, I want to design these parts for this solution, be able to have something that flies, moves, whatever it might be. And the traditional academic approach of, okay, hey, you're going to do pure math until senior year, and then you'll have one major design project. I don't think it really prepares students very well compared to, all right, you go to an internship, you see how it's actually done, you get that kind of intuition, that knowledge base, and therefore you're actually well prepped for an actual engineering environment, situation, type of problem solving. So I think the quick computer design as well as analytical tool and then rapid prototyping approach is far more applicable to the significant majority of students that go into engineering for that exact type of environment than your traditional academic environment.
So, how did you go about, securing that position at Lockheed while you were still in high school? What do you think, what trait or what, club or was it, something like that that helped you land that position at Lockheed?
Yeah, again, I had racked up a few thousand hours worth of CAD design at that point already. Interest and enjoyment was out of, okay, hey, there's this problem. I know I know how to provide a possible solution. All I need to do is go about designing it. So again, I would literally spend 9, 10 hours a day sitting in Fusion 360, which is my personal favorite CAD program. I'm a little biased to that. And be able to have a whole entire engine design, which yeah, I can use online calculators. I could use, at that time I didn't have the knowledge base I have now in terms of mathematical, from like a mathematical aspect, but I knew where to find the resources online that could calculate it for me, be able to actually get access to that information, and be able to have a whole, again, basically a whole engine design, right? So because of that, that obviously sparked interest. That recruiter that I wound up meeting, And then, that led to a series of conversations, obviously, and then ultimately, being offered a position there. So that was my process. But again, it all started from, hey, you have a design problem, you know where to access the information to solve it, go about solving it. So kind of in that regard, it kind of made my own path. Not very very much so not a traditional path. I will admit that. But it was one that I think is a unique path that I think more should probably take in terms of, all right, you want to challenge yourself, and if you want to become an engineer, all right. Well, what does an engineer do? They solve problems, they build stuff. All right, start doing that. Right. Um, so that's kind of what I did.
Yeah, it's really interesting that you say that too, because and especially in your case, it's evident, you started an engineering position and you were obviously designing and solving problems before you even got to college, right? Before you even took the engineering classes and stuff. And out of almost everyone I talk to, when I ask them like, what does it mean to be an engineer, or how did you decide on being an engineer, right? It almost always comes down to they want they like challenging themselves and they like solving problems and finding solutions to the problems, right?
Yeah.
And, I'm learning that, being an engineer, it doesn't, it's not that you have to know the calculus or you have to know all the math. You have to take all the classes and get your degree to become an engineer, right? It seems like being an being an engineer or wanting to be an engineer is like, right, having that want to design and solve problems and having that want to challenge yourself is something common I see. And I think it's really awesome in your case how obvious that is, right? You had that drive, you had the desire. Like you said, you spent 10 hours a day in your room doing CAD, solving these problems before you even took all the classes, right? Really, you were practicing engineering before you even got to, college, right? And I think that's something that's really interesting and something that's common with a lot of engineers is that desire, that drive to solve problems, even if it takes 10 hours in a day in your room during COVID, right? Like before you even get to the classes, before you even get to the theory, you have that drive to solve problems. I think that's really interesting, something that's kind of shared among engineers. So, how was your actual experience during it different? How did the actual experience differ from your expectations going into it?
Honestly, it was pretty close to what I was, I don't want to say expecting, but pretty close to what I was anticipating. In terms of, all right, obviously, high school internship versus something you might be doing more college is, there is a big difference. They do expect a lot more, which they should. Um, so going into it in high school, because I was, again, extremely design oriented, um, I kind of got thrown into a few things. I was like, okay, hey, I kind of know what I'm doing, or at least I know what I need to do to figure it out. And then that kind of only started compound going towards more into college. Um, I think there's a significant difference between a high school internship and a college internship. Obviously, again, they expect you to have a broader knowledge base at that point. You can do a lot more things. So yes, they should. And then when I got there, it was much more into the college, more college oriented work. It was a lot more optimization and a lot more, all right, hey, here's this part, find a way to make it better, figure out what conditions can it go under. Which again, I was also at the time, obviously I didn't know what I was going to be getting my hands into. But going into it and seeing what I'd be doing, it was a like, okay, I kind of feeling I'd probably be able to start doing this. But well, we're here now. All right, let's figure a way how to do it. So yeah.
Oh, that's cool, yeah. So between Lockheed and where you're at now, obviously, what is the major difference between your position at, Limitless Aero now, your own company, versus your experience at Lockheed? How do those two differ?
Yeah, they're very different. So I mean, I guess I should give a little backstory on Limitless, just to give, some context. Um, so Limitless Aeronautics, we're a company, we're developing UAS defense systems. UAS meaning basically drones and quadcopters. Um, we created this company 2 years ago to do exactly that, to take a commercial approach to defense manufacturing and basically systems design. So we primarily work on payload integration with small quadcopters, going from payload release mechanisms, munitions, our own drone technologies, grenade launchers, and really take a hands-on, all right, here's a quadcopter, here's a universal way to set on an attachment that you can now put medical kit, ammunition crate, warhead, camera, you name it, right? And have a agnostic set of solutions that can go on any kind of drone platform. So that's what we've been developing the past 2 years. Now, the back to the original question, now that we have that context, the work, the type of work that you do at a big company versus, and I'll say a very unique position that I have right now, along with our whole team. We're a team of we're a company of about 10 people right now. It's a completely different mindset to design, right? When you're at a big company, you have managers, they have managers. You have leadership that tells you, hey, we're going to be applying for this contract. This is the design problem. Here's a team of 50 engineers. Go make a design solution, right? When you work at a small startup and a small company, it's, in my opinion, it is so much more interesting because it is so much more fast paced. You quite literally you are guiding yourself. You are making your own decisions. You are completely autonomous, right? Obviously, with government compliance and regulations, but you are completely autonomous to develop what you want it, how it should work, and how it should actually go about solving a problem. So there's no instruction manual out there on how to run a company. There's no instruction manual on how to start solving a design problem that you were never trained for. Which has a very, very, very interesting set of both. It has a learning curve, don't get me wrong. Um, but it teaches you so much more about problem solving than you could learn out of any internship, out of any class. Um, Not only from a character development standpoint, but quite literally like, okay, hey, we want to solve this problem. Okay, let's figure out what we can solve in this problem and how we can actually commercialize it. How are we going to scale it? Who's going to manufacture it? How are we going to sell it? How are we going to distribute it? All these different factors that you're never taught in engineering school, right? So it turns you into a jack of all trades effectively, which it's a really awesome experience. So not only experience, but it gives you again, the autonomy to provide an actual solution that you can give to, whoever the soldiers might be that are directly requesting your kind of platforms. So basically it's you throwing yourself into the real world of, all right, there's a problem at scale. How are we going to solve this? And how are we going to do it as fast as we possibly can so that someone else might not do it, right? Or how do we beat the rest of the curve, right? Is a better way to put
Right.
it. Um, so yeah, it's a really awesome company. We have a really awesome team. We're made up of both veterans, ex-military, current military, and then obviously, some engineers, including myself. And we're making some really awesome systems, getting a lot of very interesting requests from pretty much all over the place, saying, "Hey, you obviously NATO allied countries and personnel, but them reaching out to us and saying, "Hey, I have this problem set. Your solutions might be exactly what we need. Let's set a meeting tomorrow, see how we can work together." Right. So it's really, really, really cool.
That's cool. Yeah. It sounds like you know, you have a little bit more freedom, right, at a startup versus a place like Lockheed. You can really have that experience of like, I see this problem, here's my solution for it. I don't need to talk to 100 different managers. I don't have to get these change orders and all stuff like that. You have a lot more freedom, which is, you know, can be scary a little bit, I'm sure. Maybe you felt that a little like at Lockheed, there's a process, for everything. It's always structured versus, stuff like that. You have a lot more freedom. It gives you a lot more ability to think outside the box and, come up with your own stuff versus kind of following the process, I guess.
Yeah, and that's the beauty of it. And so, okay, like for example, when you were a kid, right? You want to be an engineer. You see all these really cool rockets being developed, right? Most people's initial thought is, okay, hey, I need to start building that. I need to start being hands-on. There's a design approach. Okay, I'm gonna go here, get my fuel. I'm gonna go here, get whatever machinery, right? Obviously theoretically right now. That's engineering, right? When you go to college and you get some of these internships, it's a different approach. Like, okay, hey, do you have the approvals to get this done? Okay, have you figured out the program cost? Have you figured out how many people you're going to need that will help you solve the problem? Which, teaming is great. That's 100% needed. Getting a more, collective group effort on something is always more effective. But then being able to say, all right, hey, we have 4 different groups of people on this one project solving this one problem versus the approach of, okay, we have this design problem. I know exactly where I need to go and get my information. There's no one telling me what to do, right? We're working as a group to get the same exact thing done. So be cohesive. remove all the standard, bureaucratic processes, remove all the, communications expectations of, okay, hey, I need to talk to my manager who's going to talk to someone else's manager and then talk to, whatever engineer to work on something together. It's like, no, talk to who you need to talk to, figure out the problem, get it done right, and now find a way to scale it so you can actually make a difference, right? So that's a very big difference. The standard startup culture is all right. There's no 9 to 5. It could be a 3 a.m. You wake up and grind all the way until, I don't know, 7 or 8 p.m. or vice versa. You got some meetings a day. All right, well, I still need to solve a design problem. All right, 3 in the morning, I got it done. Right. It's a completely different ideology of going about engineering, which is something I personally fell in love with. And, as well as our team. And that's why we're, doing what we're doing.
What would you tell your younger self, that before high school or maybe right at high school, what would you tell your younger self to kind of better prepare yourself for the path that you find yourself on?
I would say never be intimidated by a problem, but look, if it's making you uncomfortable, if you don't feel like you're in your comfort zone, that means you're doing something right. If you don't know how to solve a problem, you've never done this, you've never done something before, you're completely thrown into the deep end, right? Enjoy it. There's very few times where you actually get that kind of feeling and that's where all the personal growth comes from. That's all the actual knowledge that you will keep for life will realistically come from is when you are again thrown off in the deep end. You don't know what's going on, but you will find a way, right? You always do. It's human nature to thrive and survive in harsh conditions, right? Um, so I'd say getting comfortable with not being in a comfortable space in terms of all right, you're given a design problem, you don't know how to even start going about the problem, right? But instead of shying away and quitting, no, look it dead in the eye. Okay, hey, here's a design problem. All right, I know here are the resources I have. Okay, let's start getting away at it. Let's start actually going into the problem and finding a solution. So to boil that down again to, you know, be comfortable for being thrown in the deep end and finding a problem or finding a way out of it or a way, or I shouldn't say a way out of it, a solution for it, regardless of what the conditions might be. That's definitely a very valuable lesson I've come to learn.
Oh, wow. Thanks so much, Alex. It was really great talking to you. Really great hearing your perspective from everything. Best of luck with, everything, your company and everything in the future. I hope it all works out for you.
I appreciate it. Yeah, like